One of the benefits of leveraging NSX is the ability to implement micro-segmentations. Here's what I mean by that. Let's imagine we have an ESXi host with two little VMs that are running, or two big VMs, it doesn't matter. And how do we control, if those two VMs are connected to the same exact network segment, how do we control the traffic back and forth? Now, by default, without NSX, we really can't. We don't have too much control regarding what's allowed or not allowed, but because we now have NSX and we have our overlay segment, any VMs that are connected to that overlay segment, whether they're connected on the same exact host or they're on two different hosts, we can use the concept of a distributed firewall to control exactly what is or is not allowed between those two VMs. So you can kind of think of a distributed firewall like a firewall that kind of hovers over the entire overlay topology, and then any traffic that's trying to flow over that topology is going to be governed by that firewall. And another cool feature about the distributed firewall is that it's being implemented by the NSX hosts, the transport nodes. And that means if we have a VM over here that's trying to send traffic and it's not being allowed by the distributed firewall, it's the ESXi host that's closest to that VM, the one that's running that VM, that can implement the firewall rules and prevent that traffic from wasting bandwidth even trying to go across the network. So the default policy in a distributed firewall is to allow the traffic, and in this video I'd like to show you a quick example of changing or modifying our policies as part of the distributed firewall to control and restrict what traffic is allowed. So let's put a game plan together regarding the distributed firewall. So in our topology with ESXi A and B, if we make changes to the distributed firewall, that's going to be implemented and enforced by both of these ESXi hosts. So to actually do a test here, let's go ahead and take two VMs and let's take two that are on the same ESXi host. So they could be here and here, or they could both be on the same host, but the concept is the distributed firewall lives everywhere where you have VMs connected to those overlay segments. So to really appreciate the micro-segmentation and the ability to control traffic, let's go ahead and use two VMs that are both being supported by a single ESXi host, and we can control the traffic that's trying to go between them using the distributed firewall. So for the demonstration, I'm going to go ahead and let's deploy an additional VM. So this VM here, we'll make it a web server, and let's also have it support FTP and also support ping traffic, and let's give it the IP address here of 10.10.0. and let's use 51. And for this VM, I need a client who can actually try to access the web page or FTP and so forth. So I'm going to go ahead and deploy a little flavor of Linux called Mint Linux, which has all the bells and whistles of a full-blown operating system. So we can use a browser to try to hit the web page. We have a command line where we can try FTP and ping and so forth. And we'll put the Mint device here at 10.10.0.50. and we'll put them both on ESXi A. And then before we implement some restrictive rules as part of our distributed firewall, we'll verify basic functionality, including that we can access the web page over here and that we can ping this device. And then we can also open up an FTP session. And then we can start implementing our distributed firewall rules across the board and limit one or more of those services. So here in the NSX Manager, I just want to do a quick check just to verify that nothing happened to our segment. So if we go to Networking tab here in the NSX Manager and under Connectivity, click on Segments, here is our overlay segment called Overlay Segment 10. And just furthermore, if we want to confirm our hosts involved, if we click on System and we expand Fabric and go to Hosts, here we have our two ESXi hosts, A and B, which are configured as host transport nodes, and they have a tunnel endpoint address. That's great. You'll also notice here that our tunnels are not available, and that's because between now and the previous video, I actually gracefully powered down everything, deleted the old snapshots, created new snapshots, and brought it up. And because I haven't had any traffic yet that needed to go over the tunnel, that's why it's showing here that there's no tunnels currently up. However, both of the transport nodes are up and active, so we're ready to go. And if we take a quick peek at our topology by clicking on Network and Network Topology from an NSX perspective, we still have this one segment, and we have these two VMs, which we had connected to that segment in the previous video. And they are tiny ESXi A and tiny ESXi B. So to support the services of things like FTP and web services, we're going to need to deploy some additional VMs that support those functions. So to do that, we'll hop over to the vSphere client and deploy some additional VMs. So here's the vSphere client. We are in the vSphere.nested single sign-on domain. And let's go to the VM and templates view. Here's our VMs for testing. And let me go ahead and deploy a new VM. So I have a template that can support some really cool features like web services and so forth on a really small VM. So let me go grab those. So I'm going to select local file, click on Upload Files. And with those selected, we'll click on Next. So I'm going to name this Tiny Web and FTP Server. That'll be the name of the VM. I'll put it in a folder called VMs for Testing, and we'll click on Next. And then I want to go ahead and put this on one of our 2 hosts that are enabled for NSX, and based on our plan, we want to put this on ESXi-A at .31, so we'll select that, click on Next, and it's giving me a warning message about some advanced configuration options. I'll take my risk there and click on Next, and we'll put it on the first data store on ESXi-A. We'll do thin provisioning and click on Next. As far as what segment we want to attach it to, we'll use the drop-down, click on Browse, and we want this VM to sit on the overlay segment 10. Fantastic. There's a little N there to represent it's an NSX segment. And we'll click on OK. We'll click on Next. That all looks good. And we'll click on Finish. So that is now in the process of deploying that template. So that'll act as our server. And now what we need is a device that can behave as a client. So let's go ahead and deploy a Linux machine. So let's go to the Data Store tab here. And let's go ahead and place over on ESXi-B on its data store. Let's go ahead and place an ISO file right there that we can use to deploy a brand new VM. So with that data store selected on ESXi-B, we'll click on Files. And let me make a new folder here. So we'll click on New Folder. And I'm going to call this folder ISOs on ESXi-B data store, although that's a little bit redundant because we're on the data store for ESXi-B, but that's okay. We'll click on OK. So there's the folder. We'll select it. And then we'll click on Upload Files. And I grabbed the ISO. It said that the operation failed. Let me go ahead and try that again. So I'll click on Upload Files. And that does not like it. What is wrong? Let's click on Details here. The operation failed for an undetermined reason. Could be due to a certificate that the browser doesn't trust. If you're using a self-signed or custom certificate, open the URL below in a new browser tab and accept the certificate and then retry the operation. All right, so we'll click on Accept. So we'll click on Advanced and Proceed. Oh, and this is just logging us into the actual host client for that ESXi host. So we'll click on Login. So this is ESXi-B, and we'll just do the upload from here. All right, so we'll click on Storage, and we'll go to the data store. And here at the data store, we'll go to Actions, and we'll go to Browse. And there is the ISO folder that we created earlier. And now we'll try and upload again. So we'll click Upload here. I'll select that ISO. And it's now in the process of copying it over. All right, fantastic. One way or another, we'll get it up there. So once this is done and we have that ISO sitting on the data store of ESXi-B, we can then go ahead and tell a new VM to boot from it and install Linux. All right, so back to the vSphere client. In the background, I have that copying up to this data store. So we'll go to the VMs and templates view, and we'll right-click and say, let's go ahead and create a new virtual machine. And we'll click on Next, and let's call this Mint Linux. And we'll click on Next. And we want to put this on ESXi-A also, along with the web server. That way we can demonstrate the distributed firewall protecting the traffic flow, even for 2 VMs on the same exact host. And then we'll click on Next. And I just realized that we copied the actual ISO image to the data store over on ESXi-B. So I will also have to copy it over to a data store on ESXi-A because I don't currently have shared storage. That's okay, we'll fix that in just a moment. So we'll tell this VM that's going to be using ESXi-A's data store for its files. We'll click on Next, and this is going to be a flavor of Linux. And from the dropdown, we'll choose Ubuntu 64-bit, which is right there, and we'll click on Next. And let's go ahead and give it 4 CPUs. If for some reason we need to do virtualization on that one as well, we'll expose that for assisted virtualization to the guest OS, and we'll enable performance counters. And we'll give it some more memory. Let's give it up to 4 gigabytes of RAM. That looks good. And as far as the hard disk, let's give it 75. But we'll do thin provisioning, so we're not going to waste any storage. And that looks good. And we'll scroll down. And we're going to need to move over the ISO to a data store local on ESXi-A. So we'll do that here in a second. So we'll click on Next and Finish. Also, I want to make sure I'm going to verify which network segment it's connected to. So we'll go back in, click on Edit for that VM. And then for its network adapter, we want it also connected to our overlay segment 10, which is right there. And we'll click on OK and OK. So let me go ahead and move the ISO image over to a data store on ESXi-A. Then after we do that, we can tell this Linux device to go ahead and boot from that local ISO. So we'll go to Storage. We'll go to a data store on ESXi-A. We'll create a new folder. We'll call this ISO on ESXi-A. Click on OK. So there's our new folder. We'll go into that and then click on Upload Files. And if it gives us an error, we'll go directly to the host client. But in this case, it's actually working right there. It's showing that it's 1%, 2%. So that ISO file is on its way now to the local data store here on ESXiA. And if we check over here at ESXiB, it looks like that upload there is done. However, we're not going to be using that one. We're going to be using the image over here on the data store on ESXiA because that's where the VM is going to live. So we'll give that copy operation a few moments to complete as it copies the ISO for Mint Linux over to that data store. And actually, to optimize our time while that is copying over, let's go ahead and tweak the details for our web server that we just deployed and make sure it has the IP address that we want to use, which is going to be 10.10.0.51. So we'll go back to the VM and templates view. Here's our little tiny web server. Let's just confirm the details real quick with edit settings. And it's on overlay segment 10. That looks good. So let's go ahead and power it on and make sure it has the IP address that we want to use. So with that VM selected, we'll go ahead and click on the icon to power it up. And on this little VM, VMware Tools is not installed, so when I shut it down, I want to make sure I do that from the guest OS and do it gracefully. So now that that little VM is powered on, let's open up a remote console over to that little VM. I'll go ahead and say allow and open. And here is that VM, and it did not get an IP address because I don't have DHCP services in place, so let's go ahead and configure an IP address on this device. This is DSL, darn small Linux, and it is capable of web and FTP services, but first we need to configure an IP address. So let me go ahead and click here on panel. I think we can do it right here from the panel. So from the DSL control panel, let's go to netcard config, and let's go ahead and specify the IP address that we want to use, which based on our plan is going to be 10.10.0.51. And for the default gateway, we don't have a default gateway set up yet, so it doesn't really matter what we put there, nor will it matter too much about a name server. And we'll click on apply and exit, and let's go to a command line just to verify that it took. So here at command line, we'll do an ifconfig, and sure enough, 10.10.0.51, and in just a few minutes, that IP address should show up here as well over on the right. So next, let's make sure also that web services are running. So here I've got Monkey Web that is currently enabled, SSH services are enabled, and DHCP client services are enabled, although I don't have a DHCP server yet on this network segment, so that's why we had to manually configure the IP address. All right, so this little VM, which is acting as our web server, or will be acting as our web server, is up and ready to go. Let me go ahead and minimize that remote console. Let's go back to storage and verify whether or not our copy is complete. So here on ESXiA, here we have the folder for the ISO, and sure enough, there it is. So let's go back to our Mint Linux VM and tell it to go ahead and associate that ISO in this data store so it can go ahead and boot from it. So we'll go back to the VM and templates view. We'll go to our Linux Mint device, right click, and go to edit settings. And here for the CD/DVD drive, we'll go ahead and say from the dropdown, we want to use a data store ISO file. And then furthermore, it's on the first data store. And then more to the point, it's in this folder. And there's the file right there. There's the ISO. And we'll click on OK. And when this VM boots up, we want to connect it power on to that ISO image so we can actually install from it. And we'll click on OK. All right, with that in place, we'll go ahead and power on that VM and do the install for Mint Linux on that VM. So we'll open up a remote console to that VM. And here it is. So from the menu, we'll choose Start Linux Mint 21.2 and give that a moment to process. And then we'll have the opportunity to do the installation of Linux onto the actual virtual hard disk of this VM. All right, and so from here, we'll go ahead and double click right here on the icon for Install Linux Mint. And I've got a message here about a connection failed, and that's because I don't have DHCP services on this overlay segment. That's no problem. I'll go ahead and say, don't show me that again. And then we'll choose English, click on Continue. And for the keyboard layout, we'll choose English. And I'll go ahead and opt in for the installation of the multimedia codecs and click on Continue. And then I'm going to confirm that I want to erase the disk. That's the logical disk associated with the VM and install Linux Mint. So we'll click on Install Now. And one more confirmation regarding write changes to the disk. So we'll click on Continue. We'll select our time zone. I'm in the Pacific time zone, so I'll select that and click on Continue. I'll supply a username and a password. I'm also going to specify it to log in automatically, make it a little bit easier in the lab environment, and click on Continue. All right, and then I'm going to go ahead and let that run for probably about 15 to 20 minutes so it can fully deploy Linux. And when we come back, we'll take that installed VM and we'll tweak it and configure an IP address of 10.10.0.50 and then verify our basic connectivity between it and the little web server that we also just deployed a few minutes ago. All right, that deployment is done. I also had to move this over to a network where it could get an IP address and have a default gateway because it wanted to do some updates on the internet. So now that that's done, I've moved it back over to the overlay segment. So as a quick verification, if we go back to the NSX manager here and we go to the networking tab and go to network topology. So here on this overlay segment 10, and we have 4 VMs. We'll go ahead and click that to see the details. So there's the Mint Linux VM that we just deployed, and there's the tiny web and FTP server that we deployed earlier. So now let's just go configure a static IP address on this Linux VM. So here's the remote console for this little VM, and let's go to the settings for the network. We'll click on network settings, and we'll go to the wired connection, and we'll go ahead and click on the gear to configure the details there. We'll go to IPv4, and instead of saying DHCP, we'll say manual, and we want to use the IP address on this client of 10.10.0.50. So we'll put in that IP address, we'll put in a 24-bit mask, and then for its gateway, we don't need to worry about that because there's no default gateway at the moment on that network segment. So we'll go ahead and click on apply, and then I'll go ahead and close that. And just for good measure, let's go verify that from the command line. So we'll do an ifconfig, and sure enough, 10.10.0.50, and let's also verify a basic connectivity test over to 10.10.0.51. That's our little web server. And that looks great as well. All right, so let me minimize that, and let's take a look at our topology. So currently we have our Mint Linux device here at 50 connected to the overlay segment, and we have the little web server at 51, and the compute resource for both of these VMs is ESXiA. And as we just verified, we have basic connectivity with a ping between the Linux device and the web server. Let's also just verify for a moment that other services like web services and FTP and SSH are also working. So let's bring in our little web server, and we'll make sure that web service is running, SSH is running, fantastic. Let's also bring up FTP and make that available as well. And this also shows right here the IP address of the server at 10.10.0.51. Let me go ahead and move this a little bit over to the right, and let's bring in our Mint client. So here's our Mint Linux device, and let's go ahead and close the command line. And let's do some verifications. So let's bring up a browser here on the Linux client. And let's head over to 10.10.0.51. Press enter. And that is the little web page on this little server right over here. Let me go ahead and add that as a bookmark for making it easier in the future. Click on save. Let's also try SSH. We can do that right here from the command line. So from the client, we'll type in SSH-L. We'll log in as root over to 10.10.0.51, press enter. And it looks like we have a little incompatibility issue between this client and the default Diffie-Hellman group it wants to use and what the server is willing to support. So we'll go ahead and I'm going to turn off SSH server services. So we'll just leave that one alone. So what have we verified? We verified that we can ping over there. So there's a ping to 10.10.0.51. So ping works, great, great, great. Web services work. And let's also verify FTP. Let's go ahead and open up a new shell. And let's open a connection over to 10.10.0.51. And that looks good. So I just want to verify we had connectivity over there using a few different protocols. So we have ping, which is using ICMP. We have FTP, which is using TCP with the well-known port of 21 for the initial connection there. And we're connecting over with web services, which is using TCP port 80. So let me go ahead and close that window, and let me also close my command prompts. All right, looking good. And now, the whole goal of this was to demonstrate the functionality of the distributed firewall in NSX. So let's head over to the NSX manager. So here in the NSX manager, if we went to plan and troubleshoot, on the left-hand side, we can select traffic analysis, and from right here, we can launch traceflow just to verify what currently is being permitted or denied. So if we wanted to verify that TCP port 80, for example, was allowed across the network, we can select TCP here. And for a source port, I'll pick some random high-numbered port. And for the destination port, we can put port 80, and then we can select those VMs. So we can select the client VM, and that is our Mint Linux device, and they're showing the IP address. And the target would be the VM, which is our little web server right there, is showing its IP address. This is also a great confirmation that I've got my IP address is correct. And we can click on trace. And that'll actually send TCP traffic with those ports involved, including the destination port of 80, and verify whether or not that traffic will be able to flow through the network and make it past the distributed firewall. So as that traffic is being injected in the network, by default, the distributed firewall is being checked, but by default, all the traffic is being permitted. So it's being permitted and not being blocked and being delivered over to that tiny web server. So now if we want to add restrictions with microsegmentation regarding what is allowed or isn't allowed between those two VMs, which are again sitting on the same network segment and they're sitting on the same host, what we can do is we can modify the distributed firewall. So to do that in NSX, we'd go to the security tab right there. And with security selected on the left under policy management, we'll click on distributed firewall. So there are some default policies and rules as part of the distributed firewall. But if you'll notice over here, everything is permitted. So let me go ahead and collapse the left-hand column to give us a little bit more room here. And let's add a new policy to our distributed firewall. So we'll click on Add Policy. I'll go ahead and name this Our Policy. And then a policy all by itself without any rules is pretty useless. So we'll go ahead and click on the three dots next to that policy. And we'll say, let's add a rule to that policy. And for this rule, let's go ahead and call this rule Deny HTTP. And then for the details for this rule, we can modify the source and destination. I'll go ahead and leave both as any. And then for the service, we want to make sure we match on TCP going to port 80. So for services, we'll click on the pencil here to edit that. And I'm going to do a quick search for HTTP just to limit the playing field here a little bit. And this is the one that we want right here. So for this one right here, for HTTP, it's going to match on TCP, that's the layer 4 protocol TCP, with any source port, but looking for the destination port of 80. And that's the well-known port for HTTP. So that's the one we'll select. We'll click on Apply. And then one more critical step here for this rule is that we want to go ahead and say drop or reject. So if we do a reject, it'll actually send a TCP reset back to the initial party to tell them that effectively the party's over. And this rule is going to be enabled. So we'll go ahead and publish that out. And what's happening right now is the NSX manager as the controller is pushing out this information regarding what's allowed or not allowed. And now our two ESXi hosts know about this firewall policy rule that says to reject HTTP traffic. So let me click on refresh there. So what we would expect to happen is from the Linux client going over to this server, if we try web services, that should fail if we tried to go to TCP port 80, which is the default for HTTP. However, the FTP connection and the ping connection, because they're not being denied by the distributed firewall, those should still work. So let's go ahead and test, first of all, whether ping works and the FTP works, and then we'll do the grand finale here with the web test and verify that it's not going to work because of the distributed firewall and the rule that we just added denying any traffic flows going to TCP port 80. So here is our server on the right and our client on the left. Let's go ahead and let's test with a basic ping command, which is going to be using ICMP, and that should be permitted. So we'll do a ping over to 10.10.0.51, press enter, and that is working no problem. So let's leave that running in the background. Let me go ahead and open up another shell. So in this new window, let's run FTP, and we'll type in open, and we'll open over to 10.10.0.51, and that connection should work no problem because we haven't explicitly denied in the distributed firewall FTP traffic. However, what shouldn't work is our browser. So if we open up a browser and we go to this bookmark for 10.10.0.51, that looks like it works, which is a condition we're going to face a lot with caching because we went there earlier. So I'm going to go ahead and hit the refresh button, and it is failing. So that was pulling it from the cache originally, but it is not getting there. So now as we attempt to connect, we're getting the reset message, and that reset message is coming from the NSX distributed firewall, which in our case is being implemented locally here on ESXi that's saying, sorry, you shall not pass traffic going to TCP port 80. We can also verify that is the case by going back here, and we could take this rule that we just set up and disable it. Click on publish. So we just modified the rule to make it now disabled. So it's no longer going to reject HTTP traffic going to TCP port 80. And to test that, we could come back to our client and click right here on try again. And this time it should work no problem because we're no longer denying it at the firewall. However, if we went back to the distributed firewall and enabled that rule again to reject that and clicked on publish, once again, that HTTP traffic should be denied. We could also verify that here with plan and troubleshoot by selecting the traffic analysis on the left. And here we could do that trace again. So previously, before we had the firewall rule, that traffic was allowed. But now if we do a trace trying to go to TCP to the well-known port of 80, so we'll click on retrace and click on proceed. Because the distributed firewall rule is in place, that traffic flow should be denied, and this can confirm it for us and tell us exactly where it was dropped. All right, so here we have a little indicator saying that that traffic was stopped. It wasn't able to actually get through the segment and get to the server. And down below, we have the play-by-play. So that traffic was injected into the network. It was received by ESXi-A. And then due to the distributed firewall, it was dropped by rule 2024. And if we go back to security, and on the left, we go down to our distributed firewall. Here it's reflecting that rule that effectively dropped that traffic. And if we went back to our client and clicked on refresh a few times, it's going to go ahead and no longer be able to reach that server. Once again, because this rule right here, as part of the distributed firewall, is denying that traffic. There's also a widget over here off to the right. If we scroll over a little bit, there's a little icon right on the edge there, which can tell us how many times that rule has been hit. So it also indicates here that it may take up to 15 minutes for this to populate for the hit counts. So if we were to come back to this, let's say, for example, in 15 minutes, it should show us a few hit counts where that traffic was denied. However, since we just did the test and it hasn't yet been 15 minutes, that's why it's not yet showing that information. And just for grins, let's go ahead and let's modify this rule. And instead of denying HTTP, let's go ahead and deny ICMP. And so for the service, instead of specifying TCP port 80, we'll edit that. And let's go ahead and show the current one that's selected. We'll deselect that. And let's search for ICMP. So here's one for ICMP all, which effectively is any ICMP, whether it's IP version 4 or IP version 6. So we'll click on apply and then click on publish. And if we go back to our client and we go to one of our command prompts here where we were doing pings. So we were doing pings successfully until a few moments ago, and now those are all being dropped. And if we went back to the distributed firewall rule and we disabled that rule and published it, once again, magically, because now the traffic is not being dropped, that traffic is now being allowed through once again. And that's all courtesy of the distributed firewall and the rules that we can inject as part of that distributed firewall as part of NSX.